Welcome to another video by Team MatChem. In this particular video, we will be discussing a question from the chapter Laws of Motion. We will be solving a question that is associated with the friction. A mass of 4 kg rests on a horizontal plane. When a plane is gradually inclined to an angle theta is equal to 15 degree with the horizontal, the mass is just begins to slide. What is the coefficient of static friction between the block and the surface? When you're considering the friction, there are two kinds of friction. One is called a static friction, another one is called a kinetic friction. For example, if an object is on the surface, when you are applying a force, so that means due to the friction will be resisting the applied force. That means when you are applying a force that is greater than the force due to the static friction only, you will be able to move that particular object. Okay. So in that way, if you want to calculate the static friction can be calculated as mu s into n. What do you mean by mu s? Mu s is basically, when you're considering, mu s is a constant or the coefficient of static friction. Mu s is called a coefficient of static friction. N is corresponding to the normal reaction. For example, if there is a book is on the table, there will be a force will be acting on the book by the table. That is called the normal reaction. So here what they're telling, we have a horizontal plane. On this horizontal plane, a 4 kg mass is suspended. The plane is gradually inclined to an angle 15 degree. That means like this. This is the plane. The plane is gradually inclined to an angle. Theta is equal to 15 degree. So you have placed a 4 kg of mass here. This is the 4 kg of mass. This is the 4 kg of mass. Due to the weight, the force will be generated due to acceleration due to gravity. That is equal to mass into acceleration due to gravity. So this is theta. Obviously, this angle also going to be theta. Done. So here we can see that since the object is getting slided down, the static friction will be acting opposite direction. So this is the direction of the static friction. And this is going to be the normal reaction. This is mg making an angle theta. So this particular vector mg can be resolved into this to mg cos theta, and this is to mg sin theta. This is called a resolution of a vector, mg sin theta. Done. Here we need to find out the coefficient of static friction. Mu s we need to find out. Since here we can understand that n and mg cos theta are opposite to each other, so we can write it as normal reaction n is equal to mg cos theta equal to mg cos theta. Also we can write fs is equal to mg sin theta. So we know that what is Fs? Fs is equal to mu s into n. So we can write it as Fs is equal to mu s into n, that is equal to mg sin theta. This is Fs max. What do you mean by what is the maximum value of static friction? So let it be equation number 2. Let it be equation number 1. We need to find out the value of mu s. That means you can divide equation number 2 divided by equation number 1. But you will get mu s n upon n, that is equal to mg sin theta divided by mg cos theta. mg cancel, sin theta by cos theta, that is equal to tan theta. N and n will cancel, therefore mu s is equal to tan theta. Therefore tan theta is equal to mu s. Here they are telling like what I can say, they are telling like theta is 15 degree, therefore tan 15 that is equal to 0.2679. That is nothing but is equal to the value of mu s. That is coefficient of static friction. Mu s is equal to 0.2679. Done. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.